Hi there, welcome to my new video on large language models and AI. So, in this video, I have decided to go through this very important topics regarding large language model that is called as Langchain. So, what Langchains are? Langchain is actually an SDK which can help you to interact with the large language models like ChatGPT 4, ChatGPT 3.5, which are creating a lot of noise throughout the software industry. So, how do you interact with this large language model with the help of LangChain? We'll see in this video. We'll see everything regarding how to change the behavior of your prompts. Then we will see how to set the system tone. Then we'll see about agents. We'll see about tools. We'll see about the memory of LangChain, etc., etc. So without wasting more time, let's get started. So first of all, we need to install these dependencies. So we have this pip install langchain, which langchain is actually available in the form of a library now in Python. So you can just pip install it and pip install OpenAI. So I already have these two things, so I don't need to do it again. So right now I'll not run it. You need to run it. Then these are some standard imports that I have done, OpenAI, OS, etc., etc. And then from OpenAI, I'm loading the key here and some other helper functions which we'll be seeing along. Cool. So now from the LangChains, we are importing OpenAI. In OpenAI, we are passing the model name as 3.5 because I am using GPT 3.5 Turbo. The temperature is the randomness of the output. Like it, if the temperature is less, the output is more deterministic. If the temperature is more towards one, then the output might be more random kind of. This is the object of the model. Then we pass in a prompt that is whatever prompt you want to pass. So I have passed the prompt as what is the per capita income of an individual in India. So we pass it to the LLM and it shows that as of 2020, the per capita income of India is estimated to be this much, this much. Fair enough. So the next part is how to set the tone of the chat. This we earlier also had seen in my one of my previous videos that we can set the system tone. So let's see it once again. So here in the chat we are setting the temperature as 0 for making it very deterministic. And the system message we are setting that you are a AI bot which replies the user what to eat in one short sentence. And I am asking the question from the user's end that are pizzas healthy? Should we eat them? So let's see what it gives. So the AI bot replies, pizzas can be enjoyed in moderation as a part of a balanced diet, but it's important to choose healthier toppings and crust options, etc. So this is how you can set the tone of the bot. So you can even change the tone of the bot to make the AI bot look bad or maybe something like that. Let's say we try to tell it to answer it into three sentences. Let's see how it gives the. So now it gives a longer output. So it says pizzas can be enjoyed in moderation and lean toppings, plenty of vegetables make it healthy, blah 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 blah. And you see the number of sentences have increased. So this is how you can set the system tone of the LLM using LangChain. So next that I wanted to show you is regarding text embedding. So what is embedding? Basically, it will take your text and it will convert it to numbers. And what could be the application of such thing? You can actually try to see the similarity of two text. Let's say, so OpenAI has this good thing. It has provided the embedding function here, that is OpenAI embeddings. So we created an OpenAI embeddings object here. Then we have two text here. So one text says Shabir has a parrot. Where do parrots live? And other has let's say uh, Maria has a parrot. Where do parrots live? So what we do is that we embed the text and we create a numpy array of it. So let's try to see how this embedding looks like. So it's basically a array of numbers. And now, if you want to check the similarity between these two sentences, that is these two text, then what you can do is that you can reshape it in this form, that is 1 cross minus 1, and then you pass it to the cosine similarity function that I had earlier imported from sklearn. So let's see. So it shows that there is similarity between these two sentences. That is 89% these sentences are almost similar. So what we try to do is that we try to create some other sentence only. I don't like studying. Don't make me study. So now you see the similarity quotient has decreased. So this is how you can find similarity with the help of Langchains. Cool. So next is the prompt that you give to the LangChain. So you can actually create the prompt in such a way using LangChain that let's say I ask it the question, can Narendra Modi have conversation to Mahatma Gandhi? So Narendra Modi is the current Prime Minister of India, and Mahatma Gandhi was a freedom fighter who is no more, right? So can they actually have a conversation? So you think of it, cannot, right? And now let's try to see how does a LangChain takes the prompt and tries to reason out that whether this thing is possible or not. Because if you are giving a proper prompt to the LangChain, you will get a proper output. So here you see technically Narendra Modi being the current Prime Minister of India cannot have conversation with Mahatma Gandhi as Mahatma Gandhi passed long back. So it takes in the prompt, it tries to reason out that whether the prompt is correct or not, and it gives you that okay, this prompt is not correct. Cool. Okay, so the next part is regarding to chaining in LangChain. So what is chaining in LangChain? So let's see through this example. So from LangChain, we are importing a prompt template. We are importing OpenAI. We are importing LLM chain. So we design a template here, prompt template. So what is a good name for a company that makes a product? So this is a common question that we can apply to multiple prompts. So that is actually a chain. So from the LLM, we generate the LLM object here. Then we define a chain which takes the LLM object and which takes this kind of prompt template from the prompt, and we apply this through the function. So we are giving it the question as I want a good company's name which makes colorful stocks. So it gives me the output that okay, the question was regarding what is the good company name for colorful socks, and it gave something like socktastic, something like that. Now, what is chaining is that let's say we want to apply this question to multiple prompts. Let's say I want a company name for a sock, for computer, for shoes. So for that, LangChain can be applied very nicely. So we have this input list of products here, which has socks, computers, shoes, etc. So what we can do, we can use the apply function on the LangChain object that we have created here using the input list. So just I apply the prompts here, and it shows that okay, for the socks the name could be Cozy Toes socks, for computer it could be Tech Core Solutions, for footwear it could be Footwear Factory. And if you want to generate this entire thing into a single line, so you can use the generate function. So just pass LLM generate input list, so it will generate everything in a single line. And if you want just for a single output, so you can write it in this way. You can use a predict method and you can get the output. So stochastic, that was the output it gave in the earlier list function also for sock. Cool, right? Now, what if you want to adjust multiple inputs? Let's say I have to predict, I give two inputs here, that is sad and ducks. And the template is that tell me a sad joke about ducks. So you see the adjective here is sad and this is ducks. So we can change the adjective as well. So for that you can do is that you create a template, you pass in the adjective, the arguments as parameter. Then from the prompt, you have the prompt template, which takes in the template. It takes the input variable. Here you have two variables, that is adjective and subject. Then this prompt is created, right? Then the LLM chain takes the prompt. It takes the temperature to keep it deterministic, non-deterministic, and the chain is generated. So let's try to predict what it gives. So what did the duck say when his friend died? Quack quack quack. So it is a sad joke about ducks. So let's try to change it to a happy joke about politics. So what did the politician say when he offered a free trip to the moon? So it said that one step for me, one giant leap for mankind. Wow. So it was a joke that had political tone in it, and it was a happy joke. So this is how basically chaining works in LangChains. So I hope that you have got the gist of how chaining works. Okay, so the next and the last part of this tutorial is regarding to agent and tools. So what are agents and tool in LangChain? So when employed effectively, agents can yield significant power by utilizing a large language model to make decisions, execute actions, observe outcomes, and repeat this process until the desired objective is achieved. So there are certain terms to this agent and tools. So one is the tool, that is which carries out the specified task, which includes things like Google search, database lookup, Python, REPL, etc., etc. LLM is obviously the large language model itself, and the terminology for agent is the designated agent to be utilized for a task at hand. Okay, so let's see an example of an agent in action. So from Langchain agent, we import the load tools helper function. From Langchain agents, we import the initialize agent. So this is imported. Now here Wikipedia is a tool. Okay, so we need to pip install it. So there are other tools also like LLM Math. So here I'm using two tools, that is Wikipedia and LLM Math. So from Langchain LLM import OpenAI to create the model object here. Then from tools we are loading two tools, that is Wikipedia and LLM, and we are creating this object called as tools. Now we initialize a agent using the initialize agent method, and we pass the tools, we pass the LLM, we pass the agent description, zero shot reaction react description, and some other parameters. So you can check about the parameters on OpenAI's website. So once the agent is declared, now you can ask questions to it in a smarter way. So see the question that I have asked here. Agent.run. In what year did India achieve independence? So obviously this question, it can find it in the tool called as Wikipedia. So it will go and search in Wikipedia that in which year that India achieved independence and what is the year raised to the power 3. So that let's say that year is 1947. Okay. Now we need to raise it to the power 3. So let's see what output it gives. So it is going entering a new chain. I need to find out the year India achieved independence to blah blah blah. An action it took on Wikipedia. It showed that okay, this is the summary it got from Wikipedia, and now it shows that okay, India achieved independence in this year 1947. Then using the other tool, it raised it to the power of 3 and it got the final answer as this. So this is the final answer that it got through the agent and the chain is now finished. Cool. And the last part that I wanted to show you is regarding the memory that LangChain helps you to retain that you can use on LLMs to get continuous output. So let's see this example in action. So from LangChain, we import the conversation chain. We set the LLM object here, and then we use the predict method to see the memory retention of the LangChain. So here I ask it, hi there, how are you? So it showed, okay, entering a new chain. The human says, hi there. And AI replies, okay, hi there. Nice to meet you. How are you today? Now I am going to ask it about the next question, that can we talk about climate? So okay, it retained the previous memory hi there, and it showed the and it also retained the reply that it gave me. Then it retained the question that I asked it again, and it gave the output, sure. What would you like to know about climate? So in this way, it retains memory. So you see, after some conversation, it will retain everything inside its memory and finally reply, yes, it is. We need to take action to reduce the effects on climate change and protect our planet. So cool applications you can make with the help of LangChain, right? So these were some basic things that I tried with LangChains, and definitely you can use them in your applications to make it smarter. So I hope that whatever I have shown in this video is useful for you, and let me know in the comment section below how you used it. Till then, if you like my work, please do hit the like, share, and subscribe button.